guests and speakers. So since morning session, we have seen a lot of use cases of 5G, which are going to transform our life and change the world. But actually, if we see to use the full potential of these 5G application cases, a robust and intelligent wireline is the key, without which we cannot imagine those kind of application to running successfully and transforming our life. So in today's presentation, I am going to present the key aspects of the middle mile network and how they are evolving for the future requirements. So as we can see, there are lot of last mile services in mobile, health, education, residential, enterprise. So all these services has a different kind of SLA. They have a different security requirement. They have a different capacity requirement, availability requirement, or the speed requirement. So to connect this first mile or core to the last mile, so we use a network which we term it as a middle mile. So basically middle mile network is a combination of optical and IP network. It can span a distance of few of tens kilometer to 1,000 kilometer depending on the type of application, what we are doing. And then like it can cover a multiple layer of a network, so which we traditionally name them as a mobile backhaul or the aggregation network or metro network or even NLD network. So if we see the kind of application which runs on the middle mile, so it's of course a 5G xHaul that covers the connectivity of the first mile, first haul, mid haul and backhaul. Then for ISPs, all the broadband connectivity happens through the mid mile, and it also interconnects the education and research campuses. Then as we know, there is a lot of traffic boom happening in data center interconnection. So this is one of the key traffic driver for the middle mile network. So in the data center, there is a huge requirement of traffic. So it requires a lot of capacity and low cost per bit requirement. So data center connectivity also goes through the middle mile. So similarly, the critical infrastructure where we connect the control center with a field network area for defense, transportation, then utilities, then smart cities. So all these connectivities happens through the middle mile only. And as we know, the legacy networks are already end of life. So they are already replaced by a packet network, but still a lot of application that uses and requires the traditional PDH, SDH interfaces. So those are still a valid case for the current middle mile. So those are the cases that also need to be transported through a middle mile. So this is a structure of a middle mile. So as we can see, there are three parts. One is the IP network, then optical network, and then there is a automated SDN control. So basically integrating this IP routing network with the optical network together, and then proper coordination with automated SDN control. So we can make this middle mile intelligent and more agile and more useful for carrying all these kind of traffic through a single network. So if we make it intelligent, if we say it intelligent middle mile approach, so there are key features. One is it is service aware. So different kind of service has a different SLAs in terms of the capacity, speed, then resiliency. So basically, if the network is aware of the kind of service it is carrying, so it can accordingly give a differential treatment. Similarly, different part of the network require different topologies. Some application require a ring topology or a mesh topology. So all these applications should be easily carried by adding intelligence to a middle mile approach, where optical bypass can be used for making a logical rings and replicate different kind of topologies. Then as we know that traffic demands are growing at a speed of around 30% per year. So a lot of traffic requirement is there. So keeping those in mind, the middle mile should be basically should able to scale up to meet those requirements for the future. So this adding the intelligence also add this kind of feature. Then using the proper resources, use of the resources and improving on the inefficiencies in the network resources. So we can increase the more usage and minimize the TCO of the network. So as we see, this SDN control is the major component which brings intelligence into this network. So it is the major completes all the life cycle of the support functions like multi-layer planning, multi-layer provisioning, and multi-layer troubleshooting. So it has various features like if we do a workflow engine. So basically what it does is it automates the bulk provisioning, or maybe we can do a template based provisioning, and it minimizes the human error, and then improves the overall KPIs of the network, and improves on the OPEX of the network. Similarly, closed loop automation is there. So in closed loop automation, basically it's a service assurance function where we actually take care of the network congestion or the survivability in case of fault. So using this closed loop automation, basically we improve the KPIs in the network and reduce the OPEX. So similarly in advanced analysis, so network insight functions gives the visibility of the logical and physical inventory so that we can use them more optimally, and it also has a certain more functions, like it give up a very innovative dashboards wherein we can monitor the KPIs and the SLAs and then track them and take the historical data and then analyze them and see the trends, how the traffic is going and what kind of changes are required in the network. Similarly, network health module take care of the health of the optical network, because optical network is the key to carrying all the high capacity traffic. So basically it monitors the OSNR, then fiber loss degradation. So basically it helps in the preventive maintenance, wherein if the network is degrading, losses are increasing, or OSNR is degrading, or some other important parameters are changing. So we know them in time, and then basically we can take a corrective action and then basically improve the uptime of the network. Similarly, network health also has an inbuilt OTDR functionality wherein we can monitor the fiber cut, and within the accuracy of meter we know where the fiber cut has happened and immediately take action and improve the KPIs of the network. Similarly, to take advantage of multi-vendor scenario and vendor lock-in, so multi-vendor OSS integration is one of the key feature of this. Similarly, it's a cloud-native architecture wherein we get the faster time to market, more scalability, and better development functionalities. Now, disaggregation is something which we are talking since long, so it brings a lot of benefits to the operator. So first of all, it get freedom from vendor lock-in. So instead of depending on a single vendor, now operator can partner multiple partners, and then like he can make more reliable network. Similarly, opting for the best technologies. So like we have seen that whenever there is a RFP, like operator evaluates the different feature and give the technical rating. So basically he cannot take out the best of all the vendor, but he has to compromise and choose one of the vendor and then keep his network running. So basically once we disaggregate the network, so we have a leverage to take best out of every vendor and make the best use of technologies. Now, see, for very few vendors has end-to-end portfolio, so it's very difficult for a small vendor to get into this network. So if we have a disaggregated kind of network, so a lot of new vendor can come in and work for the pieces of the network, and this way we can innovate and get the more innovation into the network. Similarly, flexible and cost-effective scale and capacity increase model. So basically, so right now we are using some bigger platforms which consumes day one the most of the power and space. So basically, we can have in a disaggregated network. So we can take a model of a small platform and then pay as you grow model. They keep on increasing, and we keep on stacking these platforms. Similarly, choosing desirable partner based on lead time of delivery. So basically, like if we want to faster time to market, so we need to immediately roll out the network. So basically, by disaggregation of the network, so there is a liberty that we can distribute the ordering among different vendors, and then quickly get the network rolling out. So basically, because of more competition, there will be a lower cost of bid because there will be more player to offer these kind of services. So these are the few things which goes in favor of operator, but still like disaggregation, once the operator start disaggregating its networks, now he comes out with a responsibility to integrate all these disaggregated networks. So basically operator need to have develop the skill set and the teams to handle these kind of requirements. So now let's see how the disaggregation looks on the on different layers. Like in IP, we disaggregate the hardware with the software, so that operator can select the best of the hardware and software options. In optical disaggregation, basically in optical there are two major components. One is the optical layer, and then another is the electrical layer. So mostly the optical layer innovation happens very slowly, maybe 6 year, 7 year, 8 year cycle is there. But on the electrical side, a lot of new innovations keeps on happening. So once we have an integrated kind of network, so operator is bound to work with only that vendor. So different vendor give different kind of innovative ideas which help in reducing the TCO and better network performance. So basically, once we disaggregate this optical layer with the electrical layer, so basically we have a leverage where we can select best of the optical technologies and best of the electrical technologies. So in first stage, it will be a partially disaggregated kind of network that will go on a large scale, where this optical layer and electrical layer, so transponder layer, will be separated, and then with the use of multi vendor controller, so we can seamlessly work for integrating these two pieces of the component. In future, there are some developments happening on the fully disaggregated network, wherein each of the component of the optical layer, like the amplifiers or ROADMs, so every component of the optical layer as well as transponder can be disaggregated and can be deployed for procured from different vendor, and they will seamlessly work together. Similarly, for control disaggregation, so cloud native platform, we disaggregate hardware with the software and use a cloud native platform for scalability and easy development. Now in optical, from the past many years, like we have not many flavor of the transponders or the electrical interfaces or the optical interfaces, wherein we use a single interface, whether we are going to 100 kilometer or maybe 1000 kilometer. So there was no various variation in the transponder type which was available. But because of data center innovations, lot of traffic demand come in access and aggregation. So it's a high time to have a different flavor of transponders. So basically now to have a better TCO, so there are two approaches to make the transponder. One is the capacity reach approach, where we have a more spectral efficiency and we can go to a longer distances, have a better performance, so that we can avoid the regenerator and reduce the overall TCO. The second approach is like we can have a transponder which is compromised on the performance, but we leverage that to reduce the cost and power consumption and miniaturize those components to have a more compact and high dense platform. So that is a power and cost optimized transport solution, more suitable for aggregation and access part. Now again, see, resiliency is one of the important part that is required from the network. So basically, if we use a WSON where there is a complete lambda switching, it is a very cost-effective way of giving a resiliency without incurring any additional cost to the additional interfaces. So we can directly switch the lambda from one part to another path and keep the network uptime high. Now in optical networks, also there are a lot of programmability is introduced. Like we can change the line rate, we can program the line rate, we can program the spectrum, we can program the lambda, then we can program the client rate. So these programmability together with the intelligence of SDN can give us a better TCO and better network performance. Similarly, on the IP side, so like there are different set of interfaces which we are using. So the product portfolio expected should have all sort of interfaces to support the services. Then, like it can support all kind of topologies. Then, right form factor, because different layer require different size of the equipment. And one more innovation that has made the IP integration possible is the IP over DWDM. So after this 7 nanometer and lower technologies are available, so we are able to miniaturize the transceivers and putting a digital coherent optics in a pluggable form in a QSFP DD kind of format, which doesn't compromise the router density. So basically these are now become a reality, and now like these can be plugged into the router, and then routers can be directly connected. So similarly, based on the application, we can use IP over optical line system, which is the open line system we have talked in the previous slide. Then we can take IP connectivity through OTN also. So these all help in IP and optical integration. So this is how the middle mile network looks after incorporating all these technologies. So on the top, we can see that we can realize IP over DWDM by directly interconnecting the routers using a QHFP DD DCO interfaces. So those will be the colored interfaces, and then it can be directly connected from one router to another router using the fiber pair. But actually, because we are miniaturizing the optical interfaces, they have a limited performance, limited capabilities. So basically, it can be possible in access and aggregation kind of scenario. And wherever we have the capacity, so we also need to have the complete fiber for doing this kind of connectivity. Now another alternative is like we can do the spectrum slicing and carry these wavelengths through the existing DWDM network with OLS disaggregated. So this will also give us advantage of having the WSON resiliency on the optical layer, which otherwise would not be possible if we directly interconnect routers. So then the resiliency will totally depend on the router logic. But here we have a well-established resiliency in transport layer, so we can leverage that. But still, because of the limited performance of the transceiver, so it can happen only on a small size network, maybe aggregation or access network. Now, if we want to interconnect a long distance network, so we need to have a high performance transceivers. So once we will try to put it in router, the router density will get compromised. So we have a separate line system, transponders. So the router can be connected with a gray interface to these transponder, and then these transponder are high performance. So without regenerator, we can carry them to a longer distances. And being open, we can stack the multiple vendor. So it's not a vendor lock because it is an open network. So we can integrate various vendors through a common OLS and efficiently utilize this fiber. So last slide. So basically these are the conclusions. So we can do operational efficiency and efficient utilization of resources to do a capex optimization and opex optimization. Then using automation, we can improve the time to market, and then using open network, we can remove the vendor lock-in. So the open integrated IP optical network with automation delivers the lowest TCO, and it maximizes the revenue potential of middle mile investment. Thanks. That's all for my side.